All right, this video we're going to go through some of the orbital settings, the main ones that we've actually got. Now, in a regular scenario, it might come up with semi-major axis and eccentricity. Basically, the first two settings, semi-major axis controls how far out your orbit is, and the eccentricity controls how circular or how oval-shaped, technically an ellipse, the orbit is, so you can kind of squish it. That being said, we find it easier, and the default settings on a lot of our practice ones are actually going to be apogee altitude and perigee altitude, though in the actual competitions, they might start off with semi-major axis. You can easily switch between the two. In fact, right now I've set for an apogee of 2,500 kilometers and a perigee of 1,500 kilometers, and I could go in and change to semi-major axis. And that setting with 25 and 1500 actually equates to a semi-major axis of 8,378.14 kilometers and an eccentricity of 0.0596, etc. But the main thing that we're going to take a look at, because it's easier to understand, especially for new people, is going to be apogee and perigee altitude. Now let's talk about what those mean. Apogee means the farthest point from the Earth, technically, that your satellite gets. In other words, it's the highest part of your orbit. And perigee means the lowest part of your orbit, or closest part. So if they're both the same, if I change these to 2,500 kilometers for each, I end up with a circular orbit centered around the Earth. Great. But I can lower the low point. And I'll go ahead and do that. Let's make it super low. We're going to bring it down to 400 kilometers, which is about where the International Space Station is. And when I come over here, we can see we're no longer a circle centered on the Earth. We're actually an ellipse with the Earth at one focus. The big thing about that is you kind of end up with an oval is effectively your orbit, is how you could imagine it. We've got the perigee, which is over here, the closest point to the Earth, and it is only 400 kilometers above the surface of the Earth. Over here, on the exact opposite side of your orbit, so perigee and apogee are always on opposite sides of the orbit, the way that the math and the physics works out. And so your apogee is going to be back over here. We can see that's the farthest point out, and it's at an altitude of 2,500 kilometers. So perigee at 400 kilometers and apogee at 2,500 kilometers. Now you may be wondering why you would do this. There's videos down below, hopefully, that talk a little bit about Kepler's laws of planetary motion, but I'll go ahead and show you this real quick just so you can understand why. So at perigee, the satellite moves real quick, and at apogee it slows down. Basically, when the satellite is in close, watch it, it speeds up, and then when it gets out far, it slows down. Now that's something that you can take advantage of to try and control where your satellite is going the slowest so that it can see longer, or it's going the fastest so that it can whip by and keep moving. These are the settings for apogee and perigee and how to imagine them. They basically control how high up your satellite is. Now, you can change where the closest point lands is located with respect to the Earth with a later setting called argument of perigee, which we'll see here in a little bit. But we wanted to give you a rundown of apogee and perigee, and the standard way of going about it is the semi-major axis and eccentricity. Now that I've made changes, I can switch over to it, and it'll tell me exactly my semi-major axis and eccentricity under these settings. All right?